discussing about the OSI model. So after completion of this module, so you will be able to know that how a device that can communicate with each other, right? How a device can communicate with each other. And based on this OSI model, which all layers are there, and based on these layers, basically what are functions those layers have. And when we are sending and when we are receiving data, right? So what do we mean by the encapsulation and decapsulation? So this is what at the end of this module you will be able to know about the OSI model, right? So before we start anything, so first let's understand what is the network set to be as, right? So in 1960s, right, whenever we have the devices, the hardware, the computers that are there, so those computers cannot communicate with each other, right? So after that, we have ARPANET, which is give birth to a network, right? Network as in when a device A will able to talk to device B. So that is based on when one of the device will able to communicate with the other device. So this is basically what it called as a packet switching between the devices. So at that time, what was happened was we have proprietary devices. For example, we have IBM devices. So IBM devices will able to communicate with each other. So they can directly communicate with each other. We have Microsoft devices that will able to communicate with each other, right? So based on this communication purpose for the network purpose. But what happened was when two different vendors that wants to communicate with each other, what will happen in this case? So they cannot communicate with each other directly. The reason is what they are using their proprietary communication between the devices. So in order to mitigate this issue, what happened was the international standard, the international bodies came up with two models. So that two models is basically one model is set to be as an OSI model, and the other one is basically a TCP IP model. So OSI model is basically being used for a reference purpose in order to understand the functionality of each and every layer. So we use this as a reference perspective. Whereas with the TCP IP model, what we referred is this model has been implemented in the device for the functionalities. So why these models are needed? Because we are talking about network. So what is the meaning of network? Network means whenever the two or more devices can communicate with each other. So device A wants to communicate with device B, right? So in this case, so in today's world, this communication is complex. This can be a complex system, right? Why this has been a complex system? Because you will think about a billion of devices through the worldwide. They are doing communication between each other. They are communicating with each other. With whom, how they are able to communicate? With the help of internet, they are able to communicate, right? Is this not a complex system? Yes, it is. So in order to understand this complex system, what we do, we got an object-oriented approach. So with this object-oriented approach, what we do is we divide this one into layers. We divide into layers, and each layer have its own functions. So whenever we are talking about layers, so we divide the communication, the network perspective in layers, right? First we divide that in layers, and that layer, each layer, with respect to each layer, they will have what? Their own functions, right? So with these functions, basically what they do is each layer will have its own function. How the functions are derived? Each layer will have its own protocol. So every layer will have its own protocol. Based on this, they will able to perform the function of it. So what is protocol? Protocol are set of rules. So before few minutes, I explained that there are two models, right? So what are these models are? One is your OSI reference model, which we refer, and the other one is a TCP IP model. With respect to this two models, right? So we will refer this one in order to understand each and every layers of it. So what do you mean by each and every layer? As I said, to break out the complex system, so whenever there are many devices, billions of devices communicating with each other, in order to break that complex system, how they are communicating with each other, we are taking an object-oriented approach. Based on this object-oriented approach, we divide this in layers. When we divide this in layers, each layer will have its own function. So based on this function, what happened is how the function comes from, because every layer will have protocol associated with that. And based on this protocol, every layer will do the function with respect to that particular layer. So taking an approach of, for example, when you are working on your PC and then when you type www.facebook.com, right? So what happened when you type www.facebook.com, how that facebook.com, starting from your laptop, from a user perspective, goes to the server of Facebook and open the URL, open the web page in your system. So basically that we will refer using an OSI. How from your home laptop, when you are using from your personal laptop, how that packet traverses all the way to the Facebook server, and then the reply from the Facebook server to open the web page, and whatever you do, basically that is being seen in your laptop, right? So when you are talking about a PC talking to a server, that means this PC is a client and this server is a server perspective. So we are talking about a client and a server perspective, right? So client and a server perspective, looking at the OSI, how the packet flow will be, now we're going to discuss about it. So the example here is, you are a client perspective. As a client, you are working on your laptop, and what you do is you open www.facebook.com. So when you open this facebook.com, from a server perspective, we have a Facebook server, and that Facebook server, so you send basically what you are doing, you are sending a request, and based on this Facebook server, it replying, and the web page is opened as facebook.com. So the first layer is a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So whenever you, as a client, when you type that in your web browser, right? So first thing hits to the application layer, because everything from a web browser perspective, this is the application. The first packet, the first thing happened in the application layer from an operating system perspective. So what does this application layer do? This application layer act as an interface to the network, and the application layer responsible to work with the user. So user are what? You are the user. You are you are opening this facebook.com. So when you open this facebook.com, what happened is, in application layer, we have some protocols. As I said, each layer will have the protocols and with certain functions. So when we are talking about a web URL, right? Whenever we are talking about web-based URLs, so in that case, what we use is HTTP or HTTPS. So this is the protocol that has been there with application layer. With application layer, other protocols, when you send an email, the protocol is SMTP. When you are sending a file transfer, FTP. When you are doing a name resolution, URL to IP, that is being DNS. So these are all, many other protocols are also there. So these are all the protocols of application layer. So when you access the web browser, so you are using what? You are using HTTP or HTTPS, right? Two different, this is secure, this is unsecure. With this, whatever you send, anything, for example, from an application perspective, you send a data, right? You send data and then you pass that to your layer 6, which is your presentation layer. In presentation layer, generally, you have these protocols, and based on these protocols, so what you are using currently is HTTP or HTTPS based. Let's say you are using HTTPS based. URL is www.facebook.com. So that is what? That is a data perspective. That data now from the application layer to the presentation layer, it been passed. So what the job of the presentation layer now? So the presentation layer have three functionalities. The first one is what? Your data conversion. The second one is for it provide an SSL security. And the third is basically compression. So three functionality your presentation layer do provide you. What do you mean by data conversion? So the application layer, whenever it sends any data, your presentation layer first job is to translate the received data. So for example, you sent a data which is said to be as A, B, C, D, E, F, right? This is the data that you are sending from your application layer. Once this one comes to the presentation layer, first job with the presentation layer will what? It will convert that to a conversion happened, right? It convert this data into a converted to a ASCII value, right? Once it is converted, what is the second thing? It been provide the security. What do you mean by security? What we are doing here is we are doing an encryption. So why we do encryption here? The reason why we do encryption is for the security purpose, so that the hacker will not able to sniff your packet, whatever you are sending. For example, secure, it will be sniff as I, J, K, like this. So now your data is being encrypted. This is what we are performing, the second functionality of it. The third functionality is what? Compression. So why we need to do a compression? Because to make the data small so that we can send the data efficiently, right? So the compression, you can say that gunzip, you can say that you can use a codec to compress your video files. You can compress your text PDF files, right? So you are performing a compression on your encrypted data after that. So first, your data comes in from your application layer. This application layer data has been translated, right? The first functionality, it's been translated to ASCII value with the binary, and then the second one is to do an encapsulation. The second one is basically a encryption. After you do encryption, it will do a compression. Once it does compression, the data is small, right? This is the three main functionality of your presentation layer. So after the presentation layer perform its three functionalities, presentation layer pass that data to the session layer. So session layer is being used for the communication purpose for the applications. So first of all, what protocol session layer use? L2TP. This is a protocol which being used for VPN sessions. We have sockets to be formed, which is being for the part of your proxy. And then we will be having using RTCP, we are using H245, S.245. These are all the protocols that been used. So generally in case of session layer, for example, a user perspective, you are a user. From you are writing an email, right? You open a web browser, and from that web browser, you open facebook.com. At the same time, you open webmail. At the same time, you are watching YouTube, right? Also, you are downloading, for example, from torrent. So 3 things from a user perspective you are doing. From a user perspective, when 3 things are doing, so every session will have every thing will have its own connection, right? Based on this connection, your session layer maintains these connections. From a user, there are multiple connections going to the end servers, right? So from email perspective, from web browser, Facebook perspective, from webmail perspective, web browser, from YouTube perspective, from torrent perspective, you are creating these sessions, right? So that is what your session layer maintains with these protocols. So this is basically provide an application programming interface to the application layer, to the transport layer. So after being session, when, for example, you opened up HTTP based facebook.com from a web browser, your application send it to the presentation layer, presentation send it to the session layer initiate the connection, initiate this session, right? It prepare a socket for that, and then it pass on to the transport layer. Remember, till this perspective, till this point, means application presentation session, right? Till this point, application presentation session, what has happened is generally whatever we are sending, those are called as data, and this data referred to as a PDU, protocol data unit. Now, when this PDU has been reached to your transport layer, this PDU, first what happened, it will break this data into what? It will break this data into segments. So whenever we refer anything in the transport layer perspective, we refer as segments. Whenever we refer from the application to the session, we refer as data or PDU. Now the PDU has been come from the session to the transport layer. The transport layer breaks that data into segments. First thing, it will break that in segments. Which all protocols are there in transport layer? So transport layer, we will have TCP, transmission control protocol. And what is the next one? We will have UDP, user datagram protocol. 2 protocols are there in this transport layer. So when we are talking about 2 protocols in this transport layers, so they will have its own functionalities. So TCP will have its own functionality, UDP will have its own functionality. Now you will ask me that how I will come to know whether I will use TCP, whether I will use UDP. Okay, you will get the answer shortly. So whenever we are talking about a transport layer, the first thing, it will convert it to the segments. So with the segments, after the segment, as we discuss about, we were referring to a client and a server model. So client, from where you are initiating a connection to the server to open a web browser in this example. So what will happen in this client perspective? The client will send, so from a client, whenever we say anything, we refer to this as an application, right? From a client side, from a sender side. From a sender side, remember that we always refer this one as an application. Whereas in case of your server side of it, we always refer to as a service. So application from a client side, service from a server side. Okay. So now I sent a request. I sent an application request based on this www.facebook.com, I use a protocol HTTPS. So whenever I say that my protocol from a application is HTTPS, right? So this is what this need a reliability. So anything in HTTP or HTTP based is need a reliability. If I say reliability, then it will use TCP. Okay. So if it is TCP, what all things that we need in terms of transport layers are? So when we talk about transport TCP, this TCP needs what? Port numbers. So basically, after this session layer, whatever the layers that we have, the transport, network, data, every layer will have its own header, right? And every header will have own informations, right? Or you can say fields. These fields are basically responsible for the function of that particular protocol. So for example, as I said, TCP is a different protocol, UDP is a different protocol. TCP functionality is different, UDP functionality is different. How, from where the functionality comes from? The functionality comes from the header. So in this header, we have different fields to perform these functionalities. Okay. The first thing of this header, when we talk about headers, the first thing is we'll see that the port numbers. When we're talking about transport, it always be the port numbers. So first, the destination port, right? So destination port has been selected based on what the protocol that we are using in application. So the protocol that we use in the application is what? HTTPS, the port number is 443, okay? I need a client-side port number as well. So client-side port number referred to as source port. If client-side port number referred to as source port, now from where I'll get this port number? Generally, whenever a client runs an operating system in the device, right? In that operating system, you have web browser, right? And that web browser is what? This web browser opens your facebook.com, it opens your webmail, it opens your YouTube, right? Or else also you open abc.com as well. So anything which will be used in terms of a web browser perspective, right? So if you see when you open in your web browser, for example, Chrome, facebook.com, again you open a new tab. So and then you open webmail, so different web page will be opened here, different web page will be opened here. So that means what? Two different unique sessions. How that unique session will be occurred? What is the logic behind it? The logic behind it is source port. So generally, the source port, whenever we open these web browser thing, whenever we are sending the email, torrent, whatever it is, the source port is randomly calculated. The source port is randomly calculated by whom? Your operating system of your device. So your source port has been randomly calculated by your operating system. Your destination port is the port which is gives by your application layer what kind of protocol that is being used. Okay. So we have something called as port number 021023. This is what referred to as well-known port numbers from 1024 to 65535, right? These are being used in this random values. So there are some restrictions. When we go in depth, we'll come to know about it, right? So starting from 1024 to 65535, from that range, your randomly port number generated from a source perspective. We added a header in this. So this is a header. This can be a header for TCP. This can be a header for UDP. So from this layer onwards, this one, network, data link, every layer will have its own header. And from this layer onwards, what we do is because we are sending the data in this format, what we do is encapsulation. We are performing an encapsulation. What do you mean by encapsulation is data which is the PDU. When pass it to the transport layer break that to segments, and based on this segment, it will attach a header in each layer. So it has been the data has been encapsulated with a header. Now it is a segment. Now this one is called as segment, right? Okay, so we discuss about what source port. We discuss about destination port. So what is the significance of this source port? Because it makes this session unique. It made the session unique when we are opening multiple web pages in a web browser. The use of destination port is basically, what is the significance is, whenever we are requesting from a client to a server, right? So server might be hosted with what? Server might be hosted with web server, multiple servers, service server, DNS servers, will have a DHCP based. We have multiple things will be hosted in this server, right? Now, when it get the request, how this server will come to know that it is based on web. So now the destination port number that is being used, so that once the TCP packet comes here, TCP segment comes here, it will check the destination port number. Based on this destination port number, it will able to identify which service it is for. So that's the reason I refer as services at the server side, application at the sender side. So it will check the destination port number to find out which service that I need to open for that. Okay. So this is what source port and destination port. We have other things in the header, which is called as sequence number and acknowledgement number as well. So just I'm giving a high level. So in our TCP class, we'll discuss everything about in detail of each layers as well. So the sequence number is what it will give us. So sequence number is a numbering to each segment. So I will have a sequence number 1 for the segment 1, 2, 3 like this, right? So I can number this one in the form of sequence number. How much data I'm transmitting, that is based on what sequence number will tell us. What is acknowledgement number? Once these packets has been received to the web server will send the acknowledgement number for each. So that means acknowledgement number is what has been received at the server side. As TCP is a reliable protocol, we are sending what? If you are sending one, if you're sending the second packet, third packet, and fourth packet, right? When we send 1, 2, 3, 4 segments from client to the server, as TCP is a reliable protocol, every packet should be delivered to the server. If any of the packet which is not being delivered, due to this reliable nature of TCP, it will retransmit back this packet. If I don't get the acknowledgement number for this packet number 3 or packet number 2, if packet number 2 is dropped, then I will retransmit that packet again. This is the nature of what the reliability means. Okay. So this is what about your sequence number and your acknowledgement number. Okay. So whenever we are talking about TCP, right? So TCP will have functions. As I said, we have TCP and UDP. Each will have its own functionalities, right? So whenever we are talking about TCP, right? So TCP will have functions. As I said, we have TCP and UDP. Each will have its own functionalities, right? So what all TCP provide us? TCP provides us reliability, right? TCP provides a reliability, order delivery of the segments. It will give us flow control. What do you mean by flow control? Is whenever from a server, right, from a client, let's say your mobile, you are downloading anything from a server will have a more capacity to send. For example, the capacity is 100 Mbps of sending. Your mobile device is having a capacity of 10 Mbps. So what will happen if the server starts sending 100 Mbps of speed, 100 Mbps of data in this from server to the client side, what will happen? Packet will drop, right? So in order not to drop this one, to overwhelm that, what will happen? They will negotiate based on this, what my capacity of receiving the packet, right? I will inform to the server. Server will start sending with the capacity, what the window of mine, and then there will be no drop. So this has happened with the help of window in our TCP header. We have a window size in our TCP header. We'll inform using window to achieve this. So this is all about TCP. in our transport layer. So we discussed about TCP, right? So what is the next protocol in transport? We have what? UDP. UDP is our another protocol that has been there. So UDP is being used for performance. It is unreliable protocol, and the header of TCP, which contains a lot of fields, but UDP is less. It will give you less overhead of the header perspective as well, because it has less functionality of it. It is unreliable protocol. So what do you mean by unreliable protocol? I will send the packet, I'll forget whether it is being received, whether it is not, I don't care about it. From a client or from a server perspective, if server is sending anything, I will forget about whether it is being received, whether it is being delivered or dropped, I don't care about it. So this means unreliable. But in terms of performance perspective, it is faster than TCP. So when we are talking about it faster than TCP, that means whenever we are talking about video, whenever we are talking about audio or voice, so these are basically need to be delivered real time, right? Real time as possible, right? So in this case, we use UDP. So UDP gives us this performance, fast transmission of this. Because when we talk about this video perspective, so video perspective, we send generally 50 frame per second, right? With 50 frame per second, for example, one frame has been lost. So what will happen? 1/30th of the second, one frame has been lost. So do you think that when you are watching an entire movie, right? So what you are sending billions of frames. So when you are sending billions of frames and out of that few frames has been lost, so do you think that there will be an impact? No, there will not be an impact. But what is the requirement is? The requirement is to send that in the real time. Send the packet in the real time so that we will have a better user experience, right? If we send this frames in a TCP perspective, okay, what will happen? It will send up a frame and then it will wait for the acknowledgement. It will send a frame, it will wait for the acknowledgement. What it cause? It will cause a delay. If it is cause a delay, then you will have a lagging in your video and audio. So that is the reason why video audio has been sent using UDP for the performance perspective. And wherever we need anything in terms of we need a reliability, we will use TCP. So this is what the difference between a TCP and a UDP. So in this, we are talking about what? We are talking about two protocols, TCP and UDP. We are talking about reliability versus performance. Wherever we need performance, we need to use UDP. Wherever we need reliability, we will use TCP. Who will decide that? Your application layer will decide that whether it will go with the transport mechanism as TCP or UDP. That been decided based on this protocol. For example, if I am using STTP, if I am using STTPS, if I am using FTP, so on. So these are basically relies on TCP. If I am using DNS, if I am using any kind of audio video transmission, if I'm using RIP, so these are all used by UDP. Okay. So wherever I don't need any reliability, I need fast, I need performance, so I will use UDP. Wherever I need reliability, I need TCP. So as I said, till this layer, what is there? Data, we will have data, and from the data is referred to as protocol data PDUs, protocol data units. This has been passed to the transport layer. The transport layer breaks that in segments, and this segment and a header will be slapped to this data, right? This header can be TCP and UDP. So this header will give us port numbers, source port number, destination port number, by which the server will identify what kind of services it will able to open for that particular port. Okay. Now from the transport, it will send it to the network layer. we know that from a client to the server, we are going to a web server using for the services from the client application. We are trying to open this web service, right? So the transport layer will identify the application and the services. This is the job of transport layer. But when we are talking about internet, right? So the packets which been transferred will be traversed in different ways, right, to reach the server. Now, how to reach this particular server? So what will be the destination where I need to reach, right? What will be the destination? What will be my final destination from a client to the server? So this is what the job of your network layer will do. So network layer will have protocols such as IP, will have NetBIOS, will have AppleTalk. So these are all the protocols that we'll have. So IP is an open standard protocol. That's the reason it is popular, and all the network layer, all the devices that we have seen so far is being used IP addressing. Based on this IP addressing, based on this network layer, it will give us what? The source IP address. Source IP address of what? The client source, from where you are trying to open this facebook.com, and which server that I want to reach. That is what the destination IP address. So we are trying to send that from a source IP address from your local machine to the destination IP address from which server that we have to go. So it will gives us an information about the end device information, sender and the receiver information, sender and receiver IP address. So to reach the final destination, what we need a network layer. In the network layer, what we need an IP address. What IP address? Source IP address from where we are sending, destination IP address to what is the final destination where the server is. So whenever we are talking about this, now my packet will be traversing through what? My packet is traversing through different networks. It will traverse through different network to reach this final destination, right? It can be any path. Think about you are going to your office with taking different paths, right? Either one day you go from this, other day what you choose this path to reach to the destination from your home to your office, right? So when this network layer pass on to this data link layer, so the data link layer has two sub layers. One is your MAC layer, media access control, and the other one is basically your logical layer. From a transport perspective, this segment has been reached to the network. The network in network layer, what we called is as packets. In the packets is basically you will have a header and the data. And this data will be encapsulated with an IP packet. With this IP packet, you will have a source IP address and a destination IP address. Now this packet has been handed over to the data link layer. So in this data link layer divide in two parts. One is your MAC layer, which is media access control layer, and the other one is your logical layer. So with this, whenever you are sending from a client to a server perspective, you know that from a application to the service, transport layer is there. From a client to the final destination, how we will reach the server, we will have the IP address. The network will tell us which path, hop by hop path to follow, it being derived from this data link layer. And also in this data link layer, we will have header. So we will have this header is called as frame. So this frame will contain the MAC address, source MAC address and destination MAC address. And then Inside that, whatever is there, your IP header, your TCP header, and your data. And then we will have a tailor for this. So every layer, transport layer and network layer, they will encapsulate using header. But in data link layer, what they do is they will have a header as well as trailer. They will encapsulate using header and trailer for the device, for the data which has been received from application. Once it's been there, and what is the significance of this trailer is basically at the receiving side of it. Whenever I'm receiving the data, what has happened is it will come to know that when the frame is started, when the frame is end, and then pass on to the upper layers. Once we have data link layer, send it to the physical layer. Now in the physical layer, what we convert this data as the bits, and then it's sent over the wire. It's sent over the wire to the receiving side, from client side to the server side of it. What we are referring here is we are referring to a OSI model while sending it, and the receiving side, basically what we are referring as a TCP/IP in which our device has been implemented. So whenever we are sending anything from a user perspective to the client, so what we will do, we will do an encapsulation. So what we do the encapsulation, your data has been received to your presentation went to the session, the data has been received at the transport. The transport layer job is to break that in segments, put its own header, encapsulate with this header, and then send it to the segments has been sent it to the network layer. Network layer will encapsulate the segment in the IP header. Based on this IP header, when it send it to the data link layer, the data link layer will encapsulate using the frame and the trailer for this. Once data link layer send it to the physical, it will convert that to bits and then send it through the internet to the receiving side of it. When the packet has been received at the receiver end, sender end is encapsulating, receiver end will be decapsulate. Once the receiver end decapsulate, it will remove, once it is checked, it will remove the frame and send the packet to the network layer. So network layer will check the destination IP address, remove the IP address, and send it to the transport. So transport layer check the destination port and then deliver it to the server, and the server, wherever the web server will be, based on the port number, it will able to access the web page. So this is how your OSI model, which is your basically our reference model which being used, a TCP/IP model which is being implemented in your devices. So this is how you open a Chrome from a web browser. The web browser will choose the source, randomly choose the source port, and then you will have a destination port as well for based on this protocol HTTP or HTTPS. IP address, source IP, destination IP address, then source MAC and destination MAC, and this will travel by hop by hop. This will travel as hop by hop to reach the destination. And then in your physical layer, it will convert to the bits. Bits will be sent through your wire, through the internet. Receiving side of it, it will check the frame. It will parse the frame at the data link layer, pass that to the network layer. It will check the packet. It will remove the IP header from that, and then pass the segment to the transport layer. The transport layer will check the header and check the port number. For example, port number is 80. It will check which port number in the server is being opened for a port number 80. That is for the web server. That is based on HTTP, and then your web page will be opened. So this is how your TCP/IP and your OSI reference model will be work. To summarize this, so from the client, what we do is we open a Chrome, and we open a Chrome where we'll open a Chrome in our PC. So once we open a Chrome in our PC, so to the data that will be here. So you are passing this data to the presentation layer where we are doing three so the data, so we open this, we open a web browser, and then from the web browser, we type as www.facebook.com from a client side. The data will be passed to the presentation layer where it do translation, compression, and then encryption. So it will come to the session layer. In this session layer, what it does is it will create a session based on the unique values that we have, the port number, source port, destination port, source IP, destination IP. So, and till this layer, right, till this part of it. So what has happened is basically in this layer, we are sending data, right? We are sending data. Once it comes to this, once it comes to the transport layer of it. So the transport layer, what we know that from the transport layer perspective, we will impose a header in this, right? So data will come as a segment. It will break that into segments, and then we will have a header in it. So once the data has been come, it be in a segment, and then your TCP or a UDP header will be imposed. So from this layer onwards, we will have what? We will have the encryption process started. So the encryption process started. So that means when the session comes to the transport, from the transport perspective, what we will have the port numbers. So port numbers as source and destination port. So after this source and destination port, the transport layer will give this to the network layer, because network layer from where we will get what? The source IP address. For example, source IP address is 192.1.1 and destination is 1.1.1.1. So final destination we are talking about. So when this packet together, it will come. So when this packet together, it will come, the segment, it will come in this layer, what we refer as a packet. And here, so we refer as packet. And as we know that in network layer also we encapsulate. So we encapsulate this entire segment in the payload for the IP. So it will encapsulate it with an IP. So IP header will be imposed with that, and it will contain the source and the destination IP address. Now this source destination IP address, this packet has been transferred where? So the packet will come to your data link layer. So the data link layer, what it does, it will include a frame. The frame will what it will have? The frame will have the MAC address, source and destination MAC address. When we are there in this layer, basically what will happen? We are traversing hop by hop. So every hop, the source and the destination frame will be changed. This frame will be passed, and then it will go to the next hop, new frame will be added to it. Once this one will be passed to the physical layer, the physical layer convert the entire thing into bits. In our wire, basically these will go in this format. So which is our, in this case, which is our Ethernet, right? Now at the receiving side of it, so packet has been received. So this bits has been received, and then physical layer will send it to the data link layer. So in data link layer, so the data link layer, what we will have, will receive this one. Once we receive this, it will check the destination MAC address, whether it is for me or not. It will check the CRC, and then what will happen? It will parse this frame and only send. So it will parse this frame and then only send the IP, TCP, UDP header with the data. So IP encapsulation will be there. So it is the process from this direction is what decryption happened. What we are having in this direction was sender side. From a sender side, we are encapsulating. From the receiver side, we are decapsulating and sending the data to our upper layers. Now, the data has been passed from the network to the transport layer. The transport layer will check the destination port. Based on this destination port, your server, which will be hosting many different services. So based on the destination port, it will identify what kind of service it has. And then it removes, and then it sends the data to the application, where your application side, you will be able to get to know the data. So the decryption happened, it will basically decapsulate this IP. Once the decapsulation of the IP, it will send the segment to the upper layer. From the TCP perspective, it will find the destination port address. Based on this destination port in the server, it will able to identify which service it is for. This is for if it is a port 80, it is for HTTP. It is port HTTPS, then it is 443 port number. Now the TCP header will be decapsulate, and then only data will be passed to the upper layer, to the application layer, to the server. So the process, what we have seen so far, when we are sending from this direction, what we are doing encapsulation. So encapsulation starts from where? Encapsulation starts from your layer 4, transport layer. It encapsulates with a TCP UDP header, TCP or UDP header. This segment, when it passes to the network layer, this will encapsulate with an IP header. The IP header, the packet will pass to the data link layer. It will encapsulate with a frame. Frame will send it to the physical layer, where it converts to the bits. Based on these bits, it will transfer through the hop by hop to reach to the server. Once the server receives, it convert back to the same frame IP, this packet, this PDU. Once this PDU has been there, it checks from the frame perspective, it checks the destination MAC address, and the CRC. Once it is checked, this frame will be parsed, and then it will send only the IP and TCP UDP, this packet. Once the packet has been there, it will check the destination IP address. Okay, this is for me. And then it will remove this IP header and then pass this segment to the transport. The transport will see whether what is the destination port number. Based on this destination port number, the server will identify what service it belongs to, remove the TCP header, and then it will send the data to. So remove the TCP header, and then it send the data to the upper layer for the application to process it. This is how basically the OSI model work when we are talking from a client to a server perspective. Thank you.